This is an Algebra 1 lesson on factoring. There's lots of ways to factor. Nobody really likes factoring all that much, and so people come up with shortcuts. Most all of them are good, and most all of them have the same mathematical basis. This is a method that we call I can factor. It has a benefit in that it always works, no matter what they are. There's some shortcuts for difference of squares, some for perfect square trinomials, different things. This always works. Sometimes it'll be a step or two extra, and sometimes not, but it's reliable and you don't have to guess to do it. Let's talk for a moment about the basis of the factoring where we go through. We're factoring quadratics. A quadratic equation is a polynomial equation of the second degree. Of course, you're aware the standard form of the quadratic equation is ax squared plus bx plus c equals y. For these purposes, a will need to be positive. A, b, and c are all integers. What are we going to do? Okay, here's our plan for factoring. Why do we want to factor? We want to factor because the roots or solutions to a quadratic equation will be when y equals 0, when the curve crosses the x-axis. The curve crosses the x-axis at when y is 0. So to solve it, we make y equals 0. We then have to find the two answers. The way we do it is we know that something times something else will be, if it's 0, then one of the somethings that we multiplied, the factors, had to have been 0. So our goal is to get all multiplication, all factors, all things that are multiplied, so it can be something times something else equals 0. So one of the somethings, or the something or the something else, had to be 0. Okay, what are the somethings? These would be individual variables or numbers, or they could be groups that are in parentheses. And it's okay to have adding and subtracting inside the parentheses, but the groups or the variables or the numbers have to be multiplied. They have to be factors. What we'll do, which I'm about to explain, is we're going to write in order. First, write in order by decreasing degree. Then factor out any common factors. Then write the common factor outside. Take out the -1 if the leading coefficient is negative. We want it to be positive. Then we'll list in the big I. We'll choose the factors that add and substitute and continue factoring. That's what we're about to do. So let's look about how we get to this point. You'll recall, here's an example, something that you're used to. We're now expanding it. Factoring is going backwards. This is in factors. X plus 2 is a factor. X minus 5 is a factor because they are things that are multiplied to give a product. We're going to expand it out to get the product. Now, when you very first started doing this expanding out, you were probably told to do something like I'm about to do, and you very quickly hopped over it because it's just so simple. But for the purpose of factoring, I want to see what the full process is. So first we would say x times the other parentheses. X distributed to the entire other parentheses plus 2 times x minus 5. Okay, so now at this point what you'll do is you'll say x times x is x squared minus 5x, then the other one 2x minus 10. You have your like terms in the middle which combine to make -3. So this turns out to be your expanded polynomial. What we're doing with factoring is we don't know any of this. We've got to get from our expanded version back to our factors. There's a problem with that. The problem is we know that when we put those like terms together there that we got -3x, but we don't know what the -3x came from. It was -5 plus 2 x's, but we don't know that. It could have been 100x minus 103x. That would be -3x. You can guess and guess until you get one that works, or you can use this method, the I can factor method, to do it. So again, what does the I can factor method do? It tells us how you got that reliably without guessing. So How did we get the middle term? It was adding the two like terms. So we want to know, where did the two like terms come from? Because what we're doing here is we're going from the expanded version backwards to the factors. And our clue is going to come in here. So what we'll do first, then, we'll go through the steps. And here's the form we're going to use. I can factor. Okay. What are we going to do? Okay, remember from the quadratic, standard form of the quadratic, that 5 is A, negative 18 is B, and negative 8 is C. We'll use those in our big I can factor. A times C goes at the top. A times C. 5 times negative 8 is negative 40. B goes at the bottom, and that is negative 18. Okay. Sometimes people say, well, is it A and B, or is it C there, or whatever? Well, okay. Here's how I remember. B is at the bottom. Ba B, ba bottom. Ba B, ba bottom. Ba B, ba bottom. The other ones go at the top, and they're multiplied. What we want to do is to find things that multiply, or factors, that multiply to negative 40. We'll list them here. Okay, well, there's negative 1 in 40. There's 1 in negative 40. There's negative 2 and 22, and so on. We'll go on down until we've listed them all. Let's see what's next. 4 and negative 10, negative 4 and 10, 5 and negative 8, negative 5 and 8. The order that you put them in doesn't matter. So now we're going to look at these, and we'll say, all of these multiply to negative 40. We'll find the one that adds to negative 18, and there it is. Okay? 2 minus 20 is negative 18. So that's the pair that we want. That is how we know where our negative 18 came from. So what did we do? We multiply all the ones that multiply to negative 40, and then we choose the one that adds to negative 18. The one that works is 2 times negative 20. So we go ahead and write that in instead of 18. So this will be plus 2x minus 20x. We write that instead of negative 18. Copy the rest of it around it. From this point, we're going to factor by grouping. So the next thing to do would be take the first two and then do the second two. And it doesn't matter which order you get them in, you put them in, you'll get the same answer. It doesn't matter. Big one, small one, doesn't matter. Which order, you'll get the same answer. Okay, so look at 5x squared and 2x. What do they have in common? X. After you factor out the x out of 5x squared, 5x remains. And from 2x, 2 remains. Negative 20x and negative 8 have negative 4 in common. After you factor out the negative 4, or you undistribute it, you get 5x plus 2. Now here is a place where people make a lot of mistakes when there's negatives. You have a tendency to want to do the knee-jerk reaction and put a negative there, but you can go back up here and find out that's not true. You can check it. Negative 4 times 5x is negative 20x. Negative 4 times 2 is negative 8. It's got to be positive to work out for this. If you've done this correctly, the thing in the parentheses will be both the same. They will be exactly the same. Okay, now we're going to undistribute that. We're going to undistribute it from the first and from the last. We're going to undistribute it, or factor it. So what do the first term and the last term have in common? Well, they have 5x plus 2 in common. Okay, after I took that out of the first one, x was left. After I divided it out of the second one, minus 4 was left. There we have our two factors. This is now factored. Okay? When you multiply this out, it'll come back down to that. This is your factoring, and here it's written a little bit prettier. to make sure that you can read it. Okay, so you might want to make sure you've written all of this down. Okay, so what we're doing here, I'm going to show you a little bit more on it. It's just using the distributive property. So what we'll do is we'll go to show you how that works out, and that's written out right here. So look through that and notice that factoring is just doing the process backwards. Okay, now we're going to work. I want you to go ahead and pause and work those, and I'll put the answers up. Okay, here are the answers. Some things to look out for. Notice that in each case we use the I can factor. I can factor. When you draw the I, you can say that I can factor. Okay. We use that to find out where the middle term came from. For example, this middle term was 9x. Where did it come from? 5 plus 4 is 9. It came from 5x plus 4x. Same deal here, same deal here. Notice that this one, if you will always, as I said at the beginning, make sure that you take out any common factors first, numerical factors particularly, your life will just get a lot easier. If you didn't do this, it would still work, but you would have a very long list to choose from, or at least a much longer list to choose from. Okay, here's 2 more to do. Do negative x squared plus x plus 20, and do 8x squared plus 32x plus 30. Work those out, pause it, and here are the answers. Okay. Does this work all the time? Yes, it does. Let's remember difference of squares. Difference of squares looks like this. It'll be 2 squares and the difference. Okay? So, for example, x squared minus 36. X squared is a perfect square. You may remember from when we were doing the previous, and that's always, and it will always work. But, you know, I don't know why, but people always forget to notice that that's difference of squares, and difference of squares comes up a whole lot of times. So let's look at some examples here of if you do it with the I can factor, it will still work. I can factor will always work. So here is the x squared minus 36